That's my name is my name is Andrew. And today I'm going to present to you a solution to the problem that is plaguing both you and the rest of the entire world. Next slide, please. Slide. Our big question is energy. That's the question. I can see that every single person in this room, at one point or another, has experienced fuel scarcity in Nigeria. One of the causes that happened in Nigeria. As a result of our national grid is collapsed. Right? And the global price of gasoline and petrol is on a constant rise. These challenges form a very interesting mix and give us particular consequences for the economy. Examples of consequences include the ever-increasing energy consumption, and this is highly significant for households. There is a monopolistic economic stimulus in experiences in the sense that we can hear that tomorrow is something called gas scarcity, and we won't have to scarcity, we will use gas scarcity. Another consequence is the fact that households now find it harder to budget for other things, being that the cost of fuel and energy has increased. So it turns out that you're spending part of your budget to get some money to buy fuel when you are bought something else that will increase your standard of living. Next slide, please. Now, looking upon these challenges and consequences of the economy, as a young engineer, of course, I would know that what solutions I provide to such big question of energy. And for solutions, whatever has to prefer has two criteria to fulfill. Number one, it must be renewable. I don't see the point in moving from one source of non-renewable energy to another one of renewable energy. It doesn't mean keep or do those ones. Number two, my solution must be accessible in the sense that if I'm solving a problem that cuts across the entirety of the world, I must have a solution that meets the entirety of the world. Now, looking at research, I was able to develop a system wherein that you can utilize biogas, that's why it's called biogas from human fecal matter. I packaged the system into a product called solar gas, and today I'm using solar gas in the entire house. Solar gas is a solution in a form of consequences in different ways. It provides a renewable alternative to fossil fuels for energy generation, reducing dependency on the final resources that we already have. Solar gas offers a cost-effective and reliable energy solution, especially in regions like ours, who have escalating prices of petrol and protein gas. By harnessing locally available resources for solar gas, we are insulated from the fact that global prices of petrol and compliance that is an insulation for us. And also, solar gas, individuals, organizations, and benefit from lower energy costs and increase financial stability. Next slide, please. Now, the second problem and the second solution profile. What is solution? What is it? What is biogas, right? Why am I saying about the solution? For those who are confused as to biogas is a very controversial gas which is released when organic matter is decomposed in an anaerobic environment. What am I saying? If you have organic matter and decompose it in a place where there's no oxygen, you get a gas which is released called biogas. Biogas is very complicated. That's not complicated. Now, what makes biogas different? In one of the biogas endeavors that I've seen in my research, there are a couple of environments that I came across. The reason why biogas is so accessible right now and affordable, if it's such a good source of energy, the first one is what? Limited access to organic matter. Where is access to organic matter has been composed? Fine, compose it, but where are they to find it? As an industrial student. But that is what they ask about. Okay, more biogas, more biogas. Why are we doing this? A lot of people say, oh, I don't want to farm. I don't have biogas to use as a farmer, so I don't want to farm. I don't have cows that can give me cow milk to decompose. The second thing is repeating the process of the repeating nature of the process following. In which that you have to get your organic matter, fill the digester, wait for the digester to digest your organic matter, empty your digester, and repeat this. This process can go on probably 1 second to 5 seconds, depending on the rate of digestion. These innovations that have come out now provide a spotlight for solar gas to shine with innovation. With solar gas, the organic matter that we get to decompose is very available in the sense that it is the organic matter that is produced every day, which is gathered somewhere and is used in stupid. So others will harness the organic matter, which is very stupid, and use the competition to produce biogas. Second innovative experience is the fact that your human participation is very minimal. You don't have to wake up every morning thinking, okay, I have a digester in the house. How do I do the digester? Okay, the digester is too low, sorry. How do I empty my digester? What I Just to add, like, for those who also are farmers who already have organic matter already, you might think that, oh, okay, this solution kind of excludes me, but it doesn't. In my design, I also make sure to include the fact that solar has external shades. What does that mean? If you already have your organic matter, let's say you wear gloves, you wear fowl, or you wear some other animals, you have the ability to feed it like this, that naturally also the solar has. The impact for this, now we've seen the challenge, we've seen the solution, right? Now obviously now it is new, it's the question now is, does it continue? Like does it become like what do you have to say? How about it? Let's tell you that capacity in fact every single person who has a use for energy, and I will use the sectors as a case study, organizations, individuals, and government. I'll start with government. So in this time, government of Oyo State was they embarked on a project to light up Oyo State. That's the project, light up Oyo. So the project is a case where you have street lights all across the streets of Oyo. You can see examples in UCH, UI, or John Airport. And this project has been very strategic and very useful. There is a case there in the sense that what these lights are powered by DC generators. And people have like sometimes when I drive, I see that okay, this generator for this technology. And I've had the experience from UI down to US. Not having using it, which is already expensive enough as it is, and also limited to do something such as lighting. With something like that, you have an opportunity where you are you have plasmas that can light the entire street, which are powered by drivers or music or buildings nearby. That is for the government. Now, for the organization, I'll start with the government is one. And UCH owes KCN over 400 million naira. Those are the issues. Over 400 million, that's the most issue. Right? If super gas was to be implemented here, the major cost a major chunk of the cost that go into lighting, heating, and cooking is covered by solar gas innovative solution in the sense that what the power that's used to power those three sectors are generated or is generated in the hospital, and that comes to play. And also for individuals, this is actually the biggest use case for solar gas in the sense that what biomass and renewable technology has been seen to be able to quickly replace natural gas for cooking. So for an individual, if you have solar gas in your house, that is our major problem on how much time for cooking gas. That's going to be useful for the cost generated by the people matter in the generators in that house. And to be solar gas is more than a product. It is a source of energy. Right? So now, after I look at the power, we have put energy and in this room, we are inviting ourselves to see that biogas can be used to cook, it can be used to power plants, and also in electric cases can be used to power generators. As we have to do right now, they are all just like there's a music sitting under a tree, and there's a right now with somebody else. Yes, sir. Now, really, I believe that you can see that by the people joining here, you have the talent, you see the solution, you see why it is foundation, you see the impact it has. Now, this question is people might have to work. Who is going to actually work? Can you work? Is it accessible to me as an individual? First thing I'm trying to tell you that as I speak to you right now, there is a working prototype of solar gas which has been installed in a house in this campus, and in the next sector of the batch, we have our first batch of governance ready for harvest. That is happening right here, right now. In terms of visibility to people all over the world, in my design and calculation, just to come up with a formula which enables you to scale up, scale down, scale wide by organizational size as needed. So then, the model right now is for a house has 4 adults and the capacity is 300 liters. But if I want to be an industry which has higher traffic, profit account for that. Bring the value and are doing getting calculated materials. Thank you. While explaining my big story, I just the idea of solar gas to multiple people. And just at the start mention of this idea, I think that I have people waiting for the government time to work well, and they told me freely, so I was like thinking about it, like, okay, you know what, come back. Once the government works well, come and put this in the house. So we can see that feasibility of solar gas is all across every single person. As long as you have a house in which you build a family, in which you are generating income as a human being, and there is a space for you, so that's why something is small. Like what you think about you can access solar gas, I can access solar gas, every single person can access solar gas. And looking at the model for a business structure, I mean, if I'm writing a vision, there should be a way to make some profit from it. Right? If I'm writing a solution, there should be something that, okay, we can discuss in this. Some of us have three business models that are for depending on choice, or depending on even the model of initiation economy. Now we have the product sale model in the sense that what I can sell a digester to you as an individual or an organization, sell you a digester unit, and then you have that installed in your house and then you just continue. So that is a one-time income for me. Or we can look at the energy supply model where I have my system where I digest fecal matter and I have biogas which I can now sell biogas to you, perhaps per cylinder or however you want it measured, I can sell biogas to you. Lastly, we also have a community-owned model, and this is one of my favorites in the sense that what it covers everybody. So this can be with partnering with NGOs or the government, whereas there is a community facility where biogas is digested, so generated, matter is digested for the entire community, and distribution takes place from them. Next slide, please. So these are some tables that attend to feasibility from the Biogas Teaching Center in China, Sichuan. They were able to do some research which I capitalized upon, saying that, oh, indeed, human fecal matter does generate biogas. It's a comparative analysis that we see against pig phases, horse phases, chicken phases, and human phases. Now, you might be wondering that, okay, as compared to pig, what are you saying? Well, I put it to you, the fact that the room is hot does not mean none of the ACs. If you are looking to say that, how much gas was this thing produce? Is it really worth my time? I would say to install it first and see the return to generate over a month, and then you can look back and say, okay, was this worth it or not? Next slide, please. Oh, okay, so, next slide. This is the prototype that was installed in the house in campus UI. As you can see, it's a very, very simple system that can be built with materials available. For the people who are on the waiting list, one of the persons in the department already explained that, okay, you know what, I don't want plastic, I don't want plastic. That I have locked down already for a soak away, and I want them to use to come here and convert it, and that is fine as well. For those who want concrete, we have concrete available. We have anaerobic materials that we use to cover up the soak away in which gas can be produced. Right here, I used some rubber drums. This is the cover. This is where gas is coming out from. This is where the digestion happens. So this is my inlet at the base. This is the exit at the base. As you can see from this pipe, as you can see from this pipe, right, this is the feeding pipe from the pit latrine. So there's a chute here that blocks it from entering the soakaway, comes into the digester. Once it's done digesting, goes back into the soakaway. So you have no problem with saying that, okay, if they take out my fecal matter, how are they going to return it back into the soakaway? Everything has been accounted for in the same gas system. In conclusion, I strongly believe that solar gas is the right step in the direction to solve most of our energy problems in Nigeria. And in the foreseeable future, I see a place where all across Oyo State, Bayelsa, and even Nasarawa, people are using this technology that emerged from the University of Ibadan. Thank you very much.
Thank you very much. I have a question. I'm not sure I get exactly how your solar gas system is different from the already existing power digesters that is being used in producing power gas at the moment. What exactly is the different feature of yours from what is already in existence?
Thank you. Please, if you can go back to the slide where we about the innovations of the solar gas system. This is innovation. So as compared to the already existing power gas, very much. Now, as compared to the systems which I already looked around and even did my research on, the systems we have at the moment are not using human physics at the moment. Then the loading also has to come with you have somebody coming around to load the digester, empty the digester, load the digester, empty the digester. So these are the places where solar gas actually stands and highlights different from what we have existing already. Thank you very much. In the choice of your raw material, why not this? Why not I want to know before the time that any property is considered before having that company.
Thank you very much. So the question is why human physics? As I stated earlier, when looking for a solution, I realized that there's human physics which actually produces. Can I go to the person slides? Thank you very much. No, the one that has the table that has human physics compared to other materials. Thank you very much. So I wouldn't lie and say that human physics is the best. No, we would not say that. Because if it was the best, then this solution would have come out a long while ago. Why we use human physics is the fact that we already have human physics existing in a place where it can be digested. To not use human physics is to just watch energy waste at this point in time. Now, look at the thermodynamic properties, the calorific, it's not here, the calorific ratio that human physics produces is not as much as the peak zone, neither as the tau zone, but it does produce biogas as you can see here. We have 0.028 daily yield per day, and this covers a daily range of 40 days. So in 40 days we have pardon me, 40 days we have about 8 meter cube of gas that we can use. If we calculate that, compound that over a month, it brings a lot of energy that we're getting wasted at the moment.
Thank you for your presentation. I guess that you've done this throughout this presented throughout the month. I think you assume right now everything is presented. But I realize that we spend a lot of time before it's actually technology, before it's describing it. So there are good and assumptions. No, basically, I would like to see that I have not to be among the partners. Thank you.
Thank you very much for your I like this solution. I like the idea of the renewable. What I didn't see, I would love to see is not the cost of development, right? And then at the end of the day, how much will it cost to provide to produce a unit of that? How then can your product compete market existing alternatives? That's how we can determine whether it will be a viable product or not. Well,
I'd like to write about 2 points. What compared to me, what's the different benefits solution? We talked about pumping, so a little bit of pumping, but it's not that how from something that has avoided against stuff. The whole stage is at least that, and now we have educated the people. But the other thing I want to bring up is so you have a software that you have writing software ready quantity of raw material. But at some point, that quantity will get spent. Now, the rate of replenishment is not how that will make it viable. When I say viable, from a profitability point of view, how would you make it viable? It will be sustainable, but not viable. After the spent quantity that is there already, any new opening around going to the toilet is not enough to sustain what you're powering, what you're producing. I don't see that argument. One last thing. The other thing is this solution now, it's is it limited to where it's located, or do you have is it built into your system to be able to move the gas, transfer the gas elsewhere for use? I don't see that Mr. Taylor.
Thank you very much for the questions. So I will start with yours, then I will back into the other questions. So just permit me to explain. Sorry, the episode. Thank you.
Thank you very much. So explain the project how it works. This is two parts. So we have two main user agents. So my system has an additional solution to the software where this is supposed to be software originally on into the digester and then the reference that is sent to it goes back into the software. So it happens that whenever the user uses a toilet, whenever you flush, this will this is constant slow again. So that's very nice to digest that, which is an anaerobic environment. From there, the composition takes place and the biogas is digested. Biogas is generated carbon. Now, in terms of sustainability, it is a continuous living system in the sense that as the possibilities to spend biogas. So in that context, in the first 15 days, 40% of balance is generated, and then the first 15 days. From the next 15 days to 25 days, now the next 40%, and then for the next 10 days, now the next 10%. So what happens is, how does it being generated? People have to get the right time. So the system has this slow, has to be to it. So the lighter one that goes to the top, lighter one which has an extent comes down. So yes, thank you. So this is the exercise which is above. So the lighter one just flows through this exit. So the lighter one flows back to the surgery, while the denser one which has an extent remains in the digester for continuous digestion and as continuously as the same process happens. Now, for the question of whether that institution stuff that where it is located in this month, as I said, this exit nozzle refers to a wolf, which has a collecting pad. The collecting pad can be compared to the that dimension of a business model so that it generates as and then sell us the single life to as many users. So the gas can be collected into bags, we collected into bags, and then compressed into this tank and compare and be spread to as many places as possible. The cost of production. I haven't gone back to the
Thank you. So a round of applause for you. As you can see, it's not easy. It's 20 under easy. Alright, so we go to our next finalist. Alright, so round up. Alright, so our next finalist. How first of all, Ali Muwa. Round of applause.
My name is Yusuf Gamboa. I'm title of my project, Development of Mathematics Using Diffusion Form, and I'm just supervised by the next. So on the 21st of October 2020, I was in household. And after the surgery, I happened to be one of the two patients, one of the two, one among patients to experience anesthesia fever. This was one of the biggest pain anyone can ever experience. Yes, yes, I had to be rejected on the calculated dosage of anesthesia per time interval. This was my first time experience with how the patients under the periodic administration of physiotherapy. Both surgeries and something that was supposed to take 1 hour 24 minutes, ended up taking 2 days. The major reason being overdose of anesthesia. Post surgery, I decided to research on the impact of manual manual injection of periodic administration of fluids, and I came across a very good friend of mine, after he was pregnant 36-year-old university lecturer and currently resides in Sokoto State, Nigeria. She also had a failed anesthesia experience when she was giving one of her victims to her age 21. At 26 weeks into her pregnancy, she was diagnosed with severe preeclampsia, and this to be placed on an intravenous FGF therapy. FGF therapy, like ablative anesthesia and some medication, being given intensive care, required to be administered into the human body at calculated dosage per time interval. Next slide. The maternal mortality ratio in Nigeria is seen at 512 per 100,000 infants. Three out of 10 of these deaths occurring due to severe preeclampsia and eclampsia, and 90% happen in low resource settings where syringe diffusion pumps are currently unavailable. Periodic medication application in Nigeria is very inefficient and unoptimized. We are on one side, we have some hospitals with a lot of patients who are start little doses of these medications per time, which is very prone to human error. And on some other hand, we have those that are understaffed but cannot afford to buy the existing syringe diffusion pump. A small survey carried out of 4 different big hospitals in Ibadan realized that only one of the four had a syringe diffusion pump, which is one of the biggest hospitals in Nigeria, the University College Hospital. And the syringe pump that they have currently do not have any way of detecting error when a malfunction occurs. Next slide. Now, the domino effect of this problem on maternal health of maternal mortality, which in turn reduces the growth rate of Nigeria's GDP. On general health, reduction in the quality of healthcare being delivered by these hospitals. And in research, syringe diffusion pumps being used as used in chemical laboratories, which in turn affects the quality of research in these laboratories. And also, the world is going open source. Scarcity of open source projects in health tech reduces interest in project development, which also has a ripple effect on economic growth. Next slide. Now, with my few years of experience studying mechanical engineering in the University of Ibadan, I came up with this solution, DOSPAL. DOSPAL is a smart syringe diffusion pump that uses IoT technology for healthcare application, with a particular emphasis in facilitating telemedicine under developing nations. As seen in the picture on the slide, DOSPAL is supposed to be connected to an intravenous line for periodic feed and medication dosage. Now, the unique selling proposition of those power, Internet of the smart device can be controlled using a mobile application. It has error detection mechanism, that is, the engine of the syringe pump has a buzzer in the end, and an alarm on the mobile app that alerts when a dispense error occurs. Next, affordability and precision. The aim is to facilitate telemedicine in low resources. Hence, low cost materials are being used in the production of the device. And lastly, open source. The project will be made open source for reproduction to enable contributions and to encourage research and development. Next step. Now, the short-term impact of this project is to give immediate access to healthcare, reduce reliance on manual methods, and on a medium term is to increase availability, affordability, to increase training and development, and on the long run, improve healthcare infrastructure, preventive healthcare measures, and in turn, research and development. Also, this project aligns with Sustainable Development Goals 3, 4, 8, and 9. Now to the overall impact. On to the engineering part of this presentation. The overall impact is to make young Aminat have access to quality healthcare, and our university students be able to carry out research. Overall, develop interest in research and development. Now to the engineering part. Next slide. So this is the block diagram, which includes the components that this particular device contains and the development step. The first step, I've acquired my material. I've designed and simulated the device with an Autodesk Tinkercad. I've designed and 3D KC using Vision 360. I've done the fabrication and construction. I've developed a virtual platform, and I'm currently from the development. Next slide. So the working principle of this syringe pump, that is those valve, and that is the interface of the mobile app that is going to be connected to it. And this is the flow chart. Now, how does those valve work? On start, calibration occurs. If calibration is successful, you have to set your operation mode, whether to manual or to virtual. Manual in this terms means you are controlling those valve from the engine, that is the keypad. You set the time interval and also the rate per time interval. You press the start button. And if you choose the virtual method, you go to the mobile app, you input the time interval, input the rate per time interval, and press the start button. All of this data, in that case, is sent to Firebase database and a microcontroller, which in turn, next steps is to check if the motor functions very well and sends the device state and direction